Okay, Ji. So indices is the topic for today. We'll be working on rules of indices because these rules will be applied in the question. Normally, this is part of paper 1, but it can also be tested in paper 2, and uh, the rules of indices can be applied on any topic in your O-level math. So it's very important. Rule number 1, if I say any value right now, as we signify a value with a, with the power 0 will be equal to 1. That means, for suppose, for the example, if we say 5 to the power 0, that will be known as 1. 10 to the power will be known as what? 10 to the power 0 will be known as 1. Similarly, there's a second rule, that is, if a to the power -1 is there, if a to the power -1 is there, we will always reciprocal a. We'll reciprocal a and make sure the power is positive. So that means if you have negative power, any number that has a negative power, let's say 5 to the power 1. So this 5 to the power 1 means 1 upon 5. If I say 10 to the power 1, this will be 1 upon 10. Rule 3, if we have, let's say, any power with any number other than 1, so this will be 1 upon a to the power n. Now, example, let's say 5 to the power 2, -2. So we can have 5 upon 1 upon 5 to the power 2, which will be 1 upon 25. So we will be solving the number if the number can be solved. Similarly, rule number 4. If we have a to the power 1 upon n, that means this should be n root a. That means whatever is in the denominator of the power will be before the root. That means, for suppose there are square roots, there are cube roots, 4 root any number. So obviously we'll be writing down in that way. For suppose, let's say that is a to the power 1 upon 4. This should be written as root 4a. Similarly, if we have a to the power 1 upon 6, this would be 6 under root a. Rule number 5. Rule number 5 says that if we have negative power, -1 upon n, so this should be positive 1 upon a to the power 1 upon n, and this should be written as 1 upon n under root a. That means any power that is negative will be reciprocal and become positive as in power, and then the power that the n that is in denominator will be used as what? Root. Rule number 6. If bases are same and multiplied, if bases are same and multiplied, powers are added. If bases are same and multiplied, powers are added. For suppose 2 to the power 3 multiply 2 to the power 2. So we can always write this as 2 to the power 3 plus 2. You can always directly solve it as well. 2 to the power 5, and then 2 to the power 5 can have its value. So these were 6 rules. Moving to 7th rule. Your 7th rule says that if a to the power m divided by a to the power n. Now you understand that the bases are same. Bases are same, but divided. That means your powers are always subtracted. So this should be a to the power m minus n. So if, for example, we have 2 to the power 5 we have 2 to the power 5 and divided 2 to the power 3. This should be known as 2, 5 minus 3, which means we will have 2 to the power square, and 2 to the power square is what? 4. Now, moving forward to 8th rule. Your 8th rule will be a to the power m, and there is a power right after the bracket. So whenever you have power right after the bracket, then the powers are multiplied. That means your a will be multiplied by m and n. So let's just put down this thing in the example. That means if there is 2 and 2 is on the power, similarly there's a power after the bracket. So this can be written as 2 to the power 6, because 2 and 3 are multiplied. We can write it down as 6. Rule number 9. Rule number 9. Whereas normally it is not tested much, but still a to the power infinity is always known as infinity. A to the power infinity is always known as infinity. Rule number 10. A to the power negative infinity will be known as a to the power a upon a to the power infinity. And since a to the power infinity means 1 upon infinity, and 1 upon infinity is always 0. Rule number 11. 9th and 10th rule are not much tested. Obviously, you should be knowing about the infinity as well. But still, rule number 11 means when bases are same and multiplied, when bases, or I will say bases are different and the powers are same. Bases are different and the powers are same. So what we're going to do is we multiply the bases keeping the power same. We multiply the bases keeping the power same. Rule number 12, we have if a bases are different but the powers are same but divided. If we divide this thing, so that means we will have a upon b to the power m. This was rule number 12. Rule number 13 for indices is that if a to the power m is equal to a to the power n, whenever the bases are equated with the same bases are equated, that means the powers can be equated directly. So we can write this as m is equal to n. That means that for suppose 2 to the power x is equal to 2 to the power 3. That means x is equal to 3 will be the answer for this. So there are almost 13 different rules that can be applied in indices. Okay, let's just attempt an example question that is from June 2010, paper 1-2, question number 4. It says evaluate 9 to the power 1 plus 9 to the power 0. You need to understand that anything to the power 1 is the same number. So that means that if 9 to the power 1 is there, we will write it as 9 plus anything to the power 0 is 1. So the answer for this is 10. Part B, it says 1 upon 9 to the power 1 upon 2. Now, there are two ways to actually do this. You can directly solve it as well. We can always show that 1 upon 9, since the power is half, we can write it as under root 1 and under root 9. Under root 1 is 1 and under root 9 is 3. But since we will be solving the rules to notify more, we can write this as 9 as 3 square. 9 as 3 square. So the power is 1 upon 2. Anything to the power 1 multiplied by 1, that means it will be 1. But if you see that 2 is being multiplied by half, so 2 ones is 2 and 2 divided by 2 becomes 1. So 3 to the power 1, the answer remains the same, that is 1 upon 3. So for this part, your answer is 1 upon 3. For part 1, your answer was 10. Question from November 2010, paper 1-1, question number 4. Now, it has the same type of questions that says 4 to the power 0. Now 4 to the power 0 will be 1 plus 4 to the power 1 will remain 4. So the answer for part A is 5. Whereas part B, what does it say? It has power with negative number. Power as negative number. So you need to change your negative to what? Positive. That means there should be 4 upon 1 to the power square. 4 upon 1 to the power square. So 4 square is 16, whereas 1 square is 1, and we don't write down 1 in the denominator. So that means the answer for part B is 16. So you always have to write your answer in blanks as well that are given in the paper. Third question. This is from November 2010, paper 1-2. Now, again, same type of question that we have, but there's a little difference that we need to understand that 5 to the power 0 will be known as what? 1. Will be written as 1. Anything to the power 0 will be written as 1. But can we see negative 5 to the power negative 1? And negative 1, that means we should reciprocal it. We can write it down as 1 upon 5. And now solve this. We will be taking LCM. Your LCM will be 5. This should be 5 minus 1, because anything that is there, we need to multiply 5 into 1 is 5 minus 1. So that means your answer will be 4 upon 5 for part A. Part B, if you note that simplify 5, now there's a square. You need to understand this square is on both the number as well as on the variable. So we will be writing down 5 square is 25. 5 square is 25, but there is a power on the variable as well. So when the power is there on the variable power will be multiplied because the power is after the bracket. So this should be x to the power 6. So the answer for 5x cubed to the power square is 25x to the power 16. Part C, you need to understand that since we have power as half, so half means under root 16 as well, but let's solve it through the indices method. 16 is the square of 4. So that will be written as 4 square upon n16. Still the power after the bracket is half. Now what we see is 2 can be multiplied by 1. So 2 ones is 2. 2 divided by 2 is 1. We can write it as 2 upon 2. Where this should also be as 16 upon 2, because 16 is also being multiplied with the power. So the end result for this is 4 to the power 1 upon n to the power 8. So we can write it as 4 upon n to the power 8. Remember to write down all your answers in the blank. This is 4 upon 5. We can write this as 25x to the power 6, whereas this should be 4 upon n to the power 8. This was question from November 2010, paper 1-2, indices. Now this question is from June 2011, paper 1-1, question number 6. You need to understand that since 8 to the power 2 upon 3 is there, you need to know that 8 is the power of 2 to the power 3. So we write 8 as 2 to the power 3, whereas 2 upon 3 are still there over the bracket. So now when I multiply 2, 3 2s will become 6, 6 upon 3 will become 6 upon 3 will become 2. So 2 to the power 2 will become what? 4. So the answer for this is 8 to the power 2 upon 3 will be what? 4. Similarly, part B, 1 upon 6 to the power negative 2. Now we need to change reciprocal this to make sure that the power become positive. So that means 6 square is 36 and 1 square is 1. We do not write down 1 in the denominator. So answer for this is 36. Okay, ji. June 2011, paper 1-2, question number 21, question number 5. So if you look at the question, it says 1 upon 4 to the power negative 2. So this should be 4 upon 1 square, because obviously we need to change your negative power to positive. So we need to reciprocal this. So the answer for this will be 16. In part B, there you see that you have 64. Now 64 can be square of, so 64 can be what 2 to the power 6 is 64. 2 to the power 6 is 64. So what we can see is 2 will be 12 upon 3, whereas 2 to the power 4. 12 divided by 3 will be 2 to the power 4. And 2 to the power 4 is 16. This is one way to do this. The other way to do this is we break it into 4. 4 cube is also 64. 2 upon 3, which means 4. This should be 6 upon 3. And when we multiply 3 into 2, it will be 6 upon 3. 4 square should be 16 as well. So both ways the answer will be accepted. The only way is that you need to understand that 2 to the power 6 is 64 and 4 to cube is also 64. Then obviously there are brackets. Then you need to multiply the powers and solve the power. In part C, you need to understand that there is numerator power as well as denominator power. So it's more easier to cancel the powers because there is a division sign. So what we can see is 4 is in the numerator, x squared is in the numerator, whereas x to the power 4 is in the denominator. So if we cancel square and 4, we will be left with square only. Whereas we have y to the power 1 in the denominator and y to the power 9 in the numerator. 1 is cancelled with 9, so you will be left with to the power 8. We have still not solved the power over the bracket. So that means this should be as 4, y to the power 8 is left in the numerator, whereas x squared is left in the denominator. 1 upon 2 is left outside the bracket. We solve it further. We have 4 and power is half. That means it will be under root 4. Under root 4 is 2. So we can write 4 as 2. This 8 that is in the power of y, 8 will be multiplied by 1. 8 ones are 8. 8 divided by 2 will be 4. So y will be 4, y to the power 4. Whereas we see in the denominator x to the power square. 2 into 1 will be 2. And 2 divided by 2 will be 1. So that means we are left with what? 2y to the power 4 upon x to the power 1. Let's just solve this thing again to try to understand this well. You need to understand that we have what? X as power. This 8. We have 8 as power. This 8 will be multiplied by 1. 8 ones will be 8. Divided by 2 will become what? 4. Whereas this 2 is in the power in the denominator, this 2 will be multiplied by 1. 2 into 1 is 2. 2 divided by 2 is what? 1. Remember that 4 to the power half is basically under root 4, and under root 4 is 2. Or you can always have 2 squared to the power 1 upon 2. So 2 squared to the power 1 upon 2 will also be written as this. That means 2 squared to the power 1 upon 2 will be 2. 2 upon 2, which is also 2 to the power 1. So both ways you can always write down 4 under root 4 as 2 or change it as 2 square and then multiply with the power to have the answer. Okay, ji. Question number 6, November 2011, paper 1-1, question number 18. You have a, that is 3 to the power square, that will be 9. Whereas a, 4 multiplied by 2 will be 8. So 9a to the power 8 will be the answer for part A. For part 2, what you need to do is 1 upon 4 to the power minus 2. This will be written as 4 upon 1 to the power square, which will be written as what? 16. Then you have part C, that is x cube is equal to 27 to the power 0. So this should be written as x cube is equal to 1. Now, if you need to understand this, you need to also understand that cube can be written as cube root of 1 on the other side. Just to eliminate this, you need to introduce, if I say that x cube is given and there is 1 on the other side, we introduce, to eliminate this, we introduce 1 upon 3 on both sides. Anything can be introduced on the left-hand side or in the right-hand side. So this should be x to the power 1, whereas anything to the power 1 will be 1. So the answer for this should be x is equal to 1 only. In part D, if you see that 12 to the power 1 upon 2 and 3 to the power 3 upon 2, we can always break these numbers. Break the numbers as in 12 to the power 1 upon 2, and we can break this 3 to the power 3 multiplied by 1 upon 2, because obviously 3 to the power 3 upon 2 can be broken into 3 and 1 upon 2. Can we see 1 upon 2 is on the both the numbers? So we can always have 12 upon 3 to the power 1 upon 2, and 3 to the power 3 is already there in the question. That means we just took 1 upon 2 out of the bracket, knowing the fact that this should be written as 12 3 upon 12 upon 27 upon 1 upon 2, 12 upon 27. This should be 3 into 12 divided by 3 will be 4, where this should be 9, 1 upon 2. Under root 4 is 2 and under root 9 is 3. Or we can always solve this through what? We can solve this through the indices method. That means 2 square, this should be 3 square, and 1 upon 2 should be on the power. That means 2 to the power 2 upon 2, 3 to the power 2 upon 2, and this can be written as 2 upon 3. So the answer for this question is 2 upon 3. This question was a trick question that is based on November 2011, paper 1 question number 18. There are less questions that are tested like this in the paper, but since obviously the examiner has to raise the difficulty level of indices, they will be testing you like this.